Multiplication and division properties of exponents. What is the difference between the multiplying and dividing property of exponents? Well, let's kind of tie a few things together. Let's think about multiplying and dividing as being opposites. Well, the same is true for adding and subtracting. So multiplying and adding make things go up, dividing and subtracting make things go down. So we're going to tie those things that go up together and the things that go down together, and they're going to help us deal with the exponents. So if we remember that a power is made up of a base and an exponent, we're going to use that to be able to come up with the rules and to discuss the rules for multiplying and dividing of exponents. So when we're multiplying, it says when the bases are alike, we add the exponents. So here we have 2 to the third times 2 squared. Based on the rule, we'd keep the base of 2, and we would add the exponents, which is 3 plus 2. This would give us 2 to the 5th power. Now, if we needed to see this explained, we can work it out a little bit. Here we have 3 2's, and here we have 2 more 2's. We can see that there are 5 2's altogether, giving us 2 to the 5th power. We would then continue to work that out, say what 2 times 2 times 2 times 2 times 2 is. We'd find out that that equals 32. Now, let's take a look at some more. Here we have m to the 5th times m to the 7th times m to the 3rd. If we combine them all, because our bases are alike, we would just add our exponents. 5 plus 7 is 12, plus 3 more is 15. Let's take a look here at another problem. Here we have 4a squared times 3a. Well, because we're multiplying, we have to put the numbers together. So 4 times 3 will give us 12. And again, the bases are alike here of a. We have 2 a's here, and there is 1 a there. So 2 plus 1 altogether gives us 3. Here's yet another example. 4r to the 6th s times 7r to the 3rd s to the 5th. And again, we're going to follow those same rules. We're going to multiply the numbers, 4 times 7, which is 28. We're going to add the exponents with the same base. So here we have 6 r's, 3 more r's. Altogether, we have 9 r's. Here we have 1 s and 5 more s's. So altogether, we have 6 s's. Now, when dividing, when the bases are alike, we're going to subtract the powers. So here we have a problem, 2 to the 5th divided by 2 to the 3rd. So if we follow our rule, which our rule is keep the base and subtract the powers, the exponents. So 5 minus 3. Well, 5 minus 3 is equal to 2. So we have 2 squared. So that would equal to 4. So now that we know that that's how does that work out separately? If we remember a little bit more, going back a little bit more here, let me move this out of the way. We remember that this is the same as saying 2 times 2 times 2 times 2 times 2 in the numerator. And in the denominator, we have 3 2's. Well, we got to remember that anything over itself is equal to 1. So I have 1, 1, 1. So here I have 1 times 1 times 1 and 2 times 2. Again, we can see how there's only 2 2's, and that would give us 4. Now, let's take a look at when we talk about numbers that are the same with the base. If we follow this rule, the base of 4, we have an exponent of 2 minus 2. Well, 2 minus 2 is equal to 0. And we know that anything with the base, any base with an exponent of 0 is always equal to 1. We can prove this because 4 squared over 4 squared is equal to 1, as is 4 times 4 divided by 4 times 4, or 16 divided by 16. All of these are all the same. These are just different ways for us to write the number 1. So let's take a look here at 4 to the 12th divided by 4 to the 8th. Keep the base, which is 4, and now we have the exponents 12 minus 8. Well, 12 take away 8 is 4, so we have 4 to the 4th power. If we work with this out, 4 times 4 times 4 times 4, we'll get 16 times 16, which will give us 256. Here we have w to the 18th divided by w to the 13th. Again, we have the base w, and we're going to subtract the exponents, 18 minus 13. What that does give us is w to the 5th power. Let's make it a little bit more complicated. Let's take a look at 2x squared divided by y to the 3rd inside the parentheses, and the whole thing raised to the 2nd power. Now, when we're looking at this, we know that nothing inside the parentheses reduces, but since there's a 2 out here, they're telling us that we have 2 of these. So let's write down 2 of them. And then we're just going to follow our rules of combination. In the numerator, we have 2 times 2, which is 4. And we have x squared times x squared, which is x to the 4th. In the denominator, we have y to the 3rd times y to the 3rd, which would give us y to the 6th. Now, what happens when you add the exponents and it turns out negative? Do we remember what to do? We've got to invert it. We've got to take the reciprocal of it. Move it from the numerator to the denominator, or denominator to the numerator, depending on what's going on. So here we have n to the 14th divided by n to the 24th. The bases are the same, so we're going to subtract the exponents. 14 minus 24. Well, we know 14 minus 24 is n to the negative 10. We don't ever leave our answers with negative exponents. So we're going to change it to be positive exponents, so we're going to invert it. We're going to take the reciprocal of it. Let's take a look at this one. 6b to the 3rd divided by 18b to the 3rd. This is similar to the one earlier when we were showing numbers along with the variables in the multiplication. So again, we're just going to work with numbers first. So when we take a look at these numbers, 6 and 18, we know that we can divide both of them by 6. 6 divided by 6 is 1, and 18 divided by 6 is 3. Then we take a look at our variables. Now we could sit here and do our variable rules of b to the 3 minus 3, which we know to be b to the 0, but can we see that they're exactly alike? Since they're exactly alike, it's kind of a big giant 1. So 1/3 times 1, our answer is just 1/3. Our last problem here, 4 divided by 3 squared, and the whole thing to the negative 2 power. Well, let's start from the parentheses first. We do have something we can simplify in here. So this works out to be 4 divided by 9 raised to the negative 2 power. Now, 4 divided by 9, nothing can get reduced there, so let's deal with this negative 2. We know that the negative means we need to invert it. We need to send the numerator to the denominator and the denominator to the numerator. So now once we do that, now we have a positive exponent of 2. And as we said earlier, that means we have 2 of these things. So let's write that down. 9 to the 4th times 9 to the 4th. We work it out. 9 times 9 is 81. And 4 times 4 is 16. And that's our final answer. So hopefully you've gotten a better handle on doing exponents with multiplying and dividing.